All right, let's look at how long division works with polynomials. And perhaps you're thinking, haven't I divided polynomials in the past without long division? Why all of a sudden do we need long division? Well, what probably happened in the past is you were working with polynomials that factored, and you'd get a common factor in the numerator and the denominator, so the division worked out quite nicely. But as you can see here, we have a polynomial that does not factor, and that's when we'll want to divide using long division. Now, long division for polynomials works the same as it does for regular number long division, except instead of working with powers of 10 one at a time, like we do with regular long division with just numbers, we're going to work with powers of x one at a time. And before we start, perhaps you're thinking, why would I ever want to divide polynomials anyway? Well, the truth is that factoring polynomials is going to require us to be able to divide polynomials, and we're going to want to factor polynomials down the road so we can draw their graphs more easily and solve problems involving those polynomials. But also, it's going to play a role in understanding the end behavior of some pretty complicated functions. So we'll want to be able to divide polynomials to see that. Anyway, let's get going here. So we're going to set this up for long division. We have our dividend, which is x squared plus 7x minus 3, and our divisor, which is x plus 1. Okay, and like I said before, instead of working with powers of 10 one at a time, like with regular number long division, we're going to work with powers of x one at a time. So we're going to start by asking, what is x squared, that's the first term of the dividend, divided by x, which is the first term of the divisor? What is x squared divided by x? Well, we'll write it out on the side. X squared divided by x. What is that? Well, x squared is x times x, and we're dividing by x. So one of those x's divides with that denominator x, and that leaves us with just x. Now, of course, you could also look at solving this using exponent laws. We have the same base of x in the numerator and the denominator, so we can just subtract exponents and keep that base. So 2 here minus the 1, which we don't write here, is 1. So we have x to the power of 1, or just x. And I'm going to write that result up here. Okay, I like to make it line up with the x term in the dividend there. It's not necessary, but it's kind of nice to keep things lined up. Okay, and then just like with regular long division, we're going to now multiply this x by our divisor, and we're going to multiply by that whole divisor of x plus 1. So what do we get? Well, x times x is x squared, so I'll write that here. And x times 1 is x, so I'll write plus x. And then we'll do the subtraction that we do when we're doing long division with just numbers. Of course, x squared minus x squared here is nothing, so I'm not even going to write 0 here. I'm just going to leave it blank. And then I've got 7x here, take away 1x here, so that's 6x. And then just like with normal number long division, I'm going to bring down the next term here. Okay, so this is going to be minus 3. All right, and then I'll repeat the process. So now we're going to take the first term of this and divide by the first term of our divisor. Now, what is 6x divided by x? Well, it's 6, and if you're not sure about that, feel free to write it out. 6x divided by x, well, those x's divide, and that leaves you with 6. So I'm going to write plus 6 here. And once again, we're going to multiply that result by the entire divisor. So 6 times x is 6x, and 6 times 1 is 6. So we'll write plus 6. We'll subtract 6x minus 6x is 0, so I'm not going to write anything there. And then for our constant terms, we have negative 3 minus 6, so that's negative 9. And this is where we can stop. And the reason we can stop is because now we're dealing with an expression that has a degree which is lower than the degree of our divisor. Okay, so we're not going to try to divide x into this constant here. So that's kind of your cue to stop. And this here is our remainder. So we could say that for this division, the answer is x plus 6 with a remainder of negative 9. So we can write x plus 6 remainder negative 9. There is a somewhat more useful way to write this result. We just say the answer is x plus 6 plus a little bit more. How much more? Well, negative 9, but that negative 9 hasn't yet been divided by x plus 1. So what we do is we write plus negative 9 over x plus 1, because it hasn't been divided yet. Okay, and of course, if you want, you could make that look a little bit better by saying x plus 6 minus 9 over x plus 1. Just factored out a negative 1 from that numerator there. Okay, all right, that's it. So now let's just do a few more examples to get a good understanding and a good grip on this process here. So x cubed minus 5x plus 9 divided by x minus 2. Now when we set this one up, make sure you notice there's no x squared term here. So what I'm going to do is I'm going to write in plus 0x squared, just so things line up. All right, the x squareds are going to line up with the x squareds and so on. And it'll make things a little easier to follow, I think. So here we go. What is x cubed divided by x? Well, I'll write it out again here. X cubed divided by x. We can go 3 minus this exponent of 1, which is 2. So we have x squared. I'll write that here. We'll multiply that result by the whole divisor here. So we get x cubed minus 2x squared. And then we'll subtract. Now, when you subtract, be very careful here. We know this is going to work out to 0. That should always happen if you're doing this correctly. But watch out here. You have 0x squared minus negative 2x squared. So that actually is the same as saying 0x squared plus 2x squared. So that's 2x squared. And we'll bring down that minus 5x. All right, and then we'll repeat the process. So 2x squared divided by x, well, that's going to give us 2x. You can write it out if you want, but it's going to be 2x. And then we'll multiply 2x by our divisor here. So we get 2x squared minus 4x. Okay, and again, watch out. When we subtract, that's 0, but be careful here. Negative 5x minus negative 4x. You're subtracting a negative. So negative 5x plus 4x is the same thing, and that, of course, is negative x. And then we'll bring down that 9, that constant term there. And we can go one more step here. We'll take that negative x and divide it by x, and that gives us negative 1. So I'll write minus 1 up top, multiply that by our divisor, and that gives us negative x plus 2, and now we can subtract, and we get 9 minus 2 is 7. And we're done. This is a lower degree than our divisor, so we can stop. So we can say, therefore, our answer from this division is x squared plus 2x minus 1, remainder 7. Or what's perhaps more useful if you had to use this result in a future calculation or something, we'll say x squared plus 2x minus 1 plus that 7, which has yet to be divided by our divisor of x minus 2. Okay, a couple more examples here. Oh, this one looks, quite a bit more intimidating perhaps because you're dealing with a quartic polynomial here. But really, it's just the same thing. So let's set it up. We have our x to the 4 term, our x cubed term, our x squared term, our x term, and our constant, and we're dividing by x minus 4. Okay, here we go. X to the 4 divided by x. Well, that gives us x cubed. And we'll multiply these two here. And that gives us x to the power of 4 minus 4x cubed. Okay, there we go. And subtract. Be careful here. Negative 3 minus negative 4 is like negative 3 plus 4, which is 1. So we have 1x cubed. Bring down the next term here. And repeat the process. X cubed divided by x. Well, that's x squared. So we'll write plus x squared. Multiply by our divisor. And that gives us x cubed minus 4x squared. All right, subtract. Again, be careful, you are subtracting a negative, so this works out to 6x squared. And we'll bring down our 5x term. And repeat, 6x squared divided by x is going to give us 6x, of course, if you want to write that down. If you don't see that right away, go ahead and write it down. And we'll multiply by our divisor, which is 6x squared minus 24x. Subtract, be careful, 5x minus negative 24x is 29x. And then we'll bring down this term here, this minus 2. Degree 1 here, degree 1 here, so we can divide again. 29x divided by 1x is 29. So we'll write plus 29. Then we'll multiply this by this entire divisor. So you get 29x minus 29 times 4, which is going to be 116. All right. And that will give us negative 2 minus negative 116, which is going to be the same as negative 2 plus 116. So that's 114. And now we will stop because now we're dealing with an expression for which the degree is lower than that of our divisor. All right, so we'll write out our answer. We'll say our answer is, okay, here we go. It's this thing here and our remainder here. So we get x cubed plus x squared plus 6x plus 29, remainder 114, or perhaps better yet, x cubed plus x squared plus 6x plus 29 plus that 114, which has not yet been divided by the x minus 4. All right, let's do one more here. Okay, be careful here. Look at our dividend. In this case, our dividend is written kind of in maybe a strange order. It's not written in that kind of descending powers of x order. So let's do that. We'll start with our highest power of x when we write it out for long division, which is x to the 4. We have a minus 2x cubed, so I'll write that next. We do not have an x squared term, so I'm going to write out plus 0x squared. We do have an x term, it's 5x, and we have a constant, which is 3. And we're going to divide that by this trinomial here, which again I will write out in descending powers of x. So we'll start with x squared plus 2x plus 1. Okay, and let's do our long division. X to the 4 divided by x squared. Well, that's going to be x squared. So I'll write it over here, and I'll multiply this by the entire divisor, which gives us x to the power of 4 plus 2x cubed plus 1x squared. And when we subtract, we get 0x to the 4, we get negative 4x cubed, and we get negative 1x squared. So now we can bring down our 5x and repeat the process again. Negative 4x cubed divided by x squared. What is that? Well, negative 4x cubed divided by x squared is negative 4x, okay? And again, if you want to write that out over here, negative 4x cubed divided by x squared, keep in mind we have the same base here, so we can subtract exponents, which would give us 3 minus 2 on that x, which is 1. So negative 4x to the 1. Okay, and now we need to multiply this by the entire divisor. So here we go. Negative 4x times x squared gives us that negative 4x cubed, which we're kind of expecting, I think, at this point. Those are always going to be the same. Negative 4x times 2x is negative 8x squared. And last but not least, we get that negative 4x, which comes from that times 1 there. All right, and subtract. Negative x squared minus negative 8x squared is 7x squared, and 5 minus negative 4 is positive 9x. And we'll bring down that constant term 3. And final time here, 7x squared divided by x squared is just 7. So we'll write plus 7, and then we'll multiply 7 by that divisor. And that gives us 7x squared plus 14x plus 7. And when we subtract here, we get negative 5x minus 4. And that's our remainder. Notice we have a degree 1 polynomial here and a degree 2 polynomial here. So we are done. We can write out our answer because degree 1 is lower than degree 2. So therefore, answer is x squared minus 4x plus 7 with the remainder, and this is interesting, the first time we've had this, a remainder that has an x in it. That's okay. But we could also write that out the other way, which is x squared minus 4x plus 7 plus negative 5x minus 4, which has yet to be divided by our divisor of x squared plus 2x plus 1. And you could also have written that divisor in the order that I was initially presented. It's up to you. It really doesn't matter. And we could stop there, but I kind of like the idea of factoring a negative 1 out of that numerator there. And when we do that, we get x squared minus 4x plus 7. Factor out a negative 1, so we end up with minus 5x plus 4 over x squared plus 2x plus 1, which I think just looks a little bit better. Of course, you could distribute this negative in here, and you would get what we had there. We just factored it out. I think it looks a bit better. Anyway, there's a bunch of examples to kind of show you how long division works with polynomials. Take care.